Hello, ladies and gentlemen. This is Mr. Green again. I am giving you another lesson in the geometry system, in the geometry text. We are on the last set of lessons in the Unit 2. So where should you all be? Even though this says you should be through Unit 1, you should be almost through with everything in Unit 2, because as soon as you finish these lessons, we will be studying for the Unit 2 exam, and I will give you a review of the Unit 2 exam. Don't panic, it is coming, okay? So, just making certain you know some things. Let's do a little bit of review right now as while we're at it. If we were looking for a mathematical statement that has been or is to be proven on a basis of established definitions and properties, we're talking about what? Hope everyone said it at the same time. The word theorem. That's what we're talking about here. It's trying to come up with theorems, right? Okay, a convincing argument that uses facts and logic to show that a conjecture statement is true. Well, that is a proof. And once we prove a statement, it is a theorem that we can then use. Beginning with the first statement, then drawing a conclusion from that, then drawing another conclusion based on one or both of the previous statements, and so on until you reach a conclusion that you want to prove. That is called a direct proof. I'm doing it directly. This is different from the indirect proof that we talked about in one of the earlier lessons. This one doesn't negate the statement and look for a contradiction. This one begins with the first statement and draws conclusion in a logical order. Okay? So, what takes a series of specific experiences or observations and arrives at a general conclusion based on them? That would be inductive reasoning. And starts with a general rule and leads to a specific conclusion used in formal proofs is deductive reasoning. Now, guys, I want to be very clear about something. You see these two statements right here? Inductive reasoning and deductive reasoning. These two statements right here are on the Unit 2 Part 2 exam. You have to define both of them. What are you going to use? You're going to take that statement right there. You're going to take that statement right there and define inductive and deductive reasoning. Those are the two statements you need to be using. Okay? I am trying to be as absolutely clear as I possibly can be. This is a 8-point question. You want to get those 8 points. It's well worth doing. Please write it down so that you get it right. Okay? Moving forward, there are two formats for proofs. One of them is called a paragraph proof, and the other one is called a two-column proof. They are defined in the lesson very, very well, and you can see them done. In a two-column proof, I've got statements and reasons as a two columns, and I'm making statements down one side, and I'm given the reason behind them on the other side. I want you to notice that over here in the paragraph proof, they still have statements with reasons as a sentence. And you're making sentences out of each one of these lines. So out of line 1, I could say, you are given that P and Q, that PQ, line 7, PQ is congruent to line XY. By definition, PQ is equal to line XY. That's the definition of congruent symbols. Definition of property of congruence. Okay? Congruent segments. So, xy is equal to pq. What is that? That's the symmetric property of equality. That's the one where we can reverse them. Right? Therefore, xy must be congruent to pq. That's the definition of congruent statements again. Once again, I could either state that in a paragraph or I could read it from the statements and the reasons right over here. Either way works. Make certain you're getting this in the lesson because it does a good job of showing you how these proofs are formatted and what you're looking for. Okay? Now, when I'm giving you a test, I more than likely will give you all of the statements. All you will have to do will be to pick out the reason for those statements. Yep, that's exactly what I'm going to do in the Unit 2 Part 2. I'm going to give you the statements, and you're going to have to fill in the reasons for them. I think you'll be able to get most of them, so don't worry about it. It's ones that we have covered in this lesson. So, or not in this lesson, in these lessons. So you should be able to get them without too much difficulty. One of the things I want to do for you is define vertical angles. I'm going to prove to you that vertical angles are congruent to each other. If you're just looking at these things right here, I hope you see that this angle right here is congruent to that angle right down there. And that this angle over here is congruent to this angle over here. Right? Congruent meaning they have the same measurement. So if I'm looking at this one here, this angle right here is congruent to this angle right here. This angle right here is congruent to this angle right here. In both sets of them, I have two pairs of vertical angles. And all pairs of vertical angles are congruent to each other. Okay? Vertical does not mean up and down. Vertical means that they're opposite each other. So if I've got two lines that intersect, they form vertical angles. And the angles that they form, the opposite angles that are formed, will be congruent to each other. Let me give you some numbers here. 1, 2, 3, and 4. So that means angle 1 is congruent to angle 3. That means angle 2 is congruent to angle 4. Okay? Let's try this. 9, 8, 7, and 6. That means that angle 9 is congruent to angle 7. That means that angle 6 is congruent to angle 8. Did it matter how I numbered them? Nah. Did it matter which ones were congruent? Yes, the ones opposite them are congruent. 4 and 2 are congruent. I'm hoping you're seeing that vertical angles are congruent. Let me go about the process of showing you how we would do this with a proof. Here's the theorem. It's in your textbooks. It says theorem 2.3, vertical angle theorem. Two angles form a pair of vertical angles, then they are congruent. So, if I'm going to write the proof, what's the next thing I'm going to do? I'm going to write down a drawing. I'm going to draw myself a pair of lines. I'm going to number the angles 1, 2, 3, and 4 so that I have a pair of angles that are vertical angles, 1 and 3. So let me go about the proof here. Now that I've got a drawing, I'm going to write down my given statement. Well, just looking at the theorem here, two angles form a pair of vertical angles. That's going to be my given statement. Angles 1 and 3 are vertical angles. That's two angles. They form a pair of vertical angles. What am I trying to prove? I'm trying to prove that angle 1 is congruent to angle 3. Do you see where I got the given and the proof and how they're in the theorem and how one is the hypothesis of the if statement up here? The hypothesis. Come on, pen, work with me. Thank you. The hypothesis. The other one is the conclusion. One of them is the if statement. The other one is the then portion of it. That is all I've been doing here is we're trying to identify the parts of the theorem for you. Okay? So, what do I do next? Give me a piece of paper here. A blank sheet of paper. What I'm going to do next is I'm going to say number 1. Angle 1 and angle 3 are vertical. That was given. Okay? This is my statement. And this is my reason. Okay? So statement number 2. Angle 1 is supplementary to angle 2. That's the definition of supplementary angles, isn't it? Well, why do I know 1 and 2 are supplementary? They were formed by a straight line, weren't they? Yeah, they are. So that would be you could say those are supplementary. Well, you know what? If they're supplementary, then angle 1 plus angle 2 has to equal 180 degrees, right? That is supplementary theorem, right? Supplementary angle theorem. have to supplementary, they have to add up to 180 degrees. Well, if 1 and 2 add up to 180 degrees, guess what? I could also say that 2, angle 2, and angle 3 are supplementary. Why? Well, that's the same definition of supplementary. And I could say right here, number 5, angle 2 plus angle 3 equals 180 degrees. Why? That's that same supplementary, this same theorem right here, right? Same thing. So here we go. Here's the trick. And number 6. I'm going to say that angle 1 plus angle 2 equals angle 2 plus angle 3. Well, how'd you do that? See how they're both equal to 180? It was a substitution. I substituted one value for the other value. And now guess what I'm going to do? I'm going to subtract. I'm going to subtract angle 2 from both sides. And I'm going to say that angle 1 is now going to be angle 1 plus angle 2 minus angle 2. It's going to be equal to angle 2 minus angle 2 plus angle 3. And that's the subtraction property of equality. Well, what can I do next? 8. I'm going to say that angle 1 is now equal to angle 2. Why is that? Well, that was just gathering terms. Is that a math term? Well, that is something that you were defined in algebra. You were taught how to gather your like terms together, right? Where did I go wrong here? Well, I wasn't using the congruent symbol in here, right? And so basically a lot of these are congruent rather than equal. But this is the way you would write that proof. I think they do it more elegantly in the lesson, but the whole point here is you can see how I went from one step to the next step using logic and coming up with a reason for why I'm doing it. Using logic, coming up with a reason, and then, oh, look at this, I got 2's on both sides, so subtract the 2's from both sides, algebraic statement, substitution, I'm done. I'm there. I've proven them congruent. And that's how you write a proof. And on top of that, we now know that vertical angles are congruent, and we will use that in proofs all year long. So you need to make certain you remember it. You see this number right here? Theorem 2-3. If you look in the back of the book, it's got a little section called Theorology. It lists all the theorems that are in a chapter. If you ever forget, well, what theorems have we covered in this chapter? They're in the back of the book under the appendix area, right there in that general area. And you can get all the theorems that are in a particular chapter. Good idea to look at that before you go take the test, because guess what? Those are the ones you're going to get tested over every time, right? And in Unit 2, there are a bunch of theorems, and there's a bunch of algebraic things that we have done. You need to look at that stuff, okay? So, call me, email me, K-mail me, give me that course number and section number, because it really does help me find you quicker. Looking forward to talking to you next time we're together.